Hey guys, so today's lesson is about climate change, which is probably something you've been learning about for years now, but hopefully there will be something new for you in this lesson. So in this climate change lesson, we're going to be going over the difference between climate, weather, climate change, and global warming. We're going to look at some of the historic causes of climate change and compare that to some of the current causes of climate change. Then we're briefly going to talk about some of the different impacts of climate change, including severe weather, and then the evidence that climate change is actually happening. So first of all, some definitions. Weather is just short-term temperature and precipitation as well as atmospheric conditions. So for example, if we say it is like 25 degrees and sunny, that is weather. Climate is long-term patterns of the weather in an area. So we're talking like years, decades, that sort of thing. Global warming is the rising average temperature on Earth as a whole. So if we take all of the land and all of the oceans and the atmosphere and average out the weather, or sorry, not the weather, the temperature, over the past century, we can see that that has been gradually increasing. However, in some areas, it's not increasing. In some areas, it's not getting warmer. It's just on average, the Earth is getting warmer. And so because some people weren't believing in global warming just because their small little area of the Earth wasn't warming, we have kind of moved away from talking about it in terms of global warming and now talk about it in terms of climate change. So climate change is a significant and lasting change in the distribution of weather patterns. So for example, if your area over the past couple decades has gotten way warmer or way cooler or way drier or way wetter, all of those would be examples of climate change. And this isn't just happening on average, this is happening in millions of different regions all over the world. Both climate change and global warming are still currently happening, but climate change is the one that's easier to see on a regional scale. So for example, if you have had a whole bunch of, like the past decade, you have had like insanely cold, wet, snowy winters, you might say, well, I don't believe in global warming because my little area of the world isn't warming. But you might be able to then see how climate change is applying to you when your climate has gotten colder and wetter. So yeah, global warming just refers to the average temperature increases that the entire world has been experiencing on average, whereas climate change refers to any change in temperature or precipitation that happens at the regional level. Climate change is not new. Climate change has been happening for millennia, but the factors that cause climate change have changed. So in the past, climate change happened very naturally and not because of human or any animal's interference. Nowadays, climate change is happening because of human actions. So that's one of the differences. So let's look at some of these historic causes of climate change. The first is solar output. So that is just the amount of radiation that's being emitted by the sun. And this actually cycles. There are warm cycles and cool cycles. So the temperature of the sun essentially like goes up and down in very predictable ways. When less energy is being released from the sun, that tends to cause the Earth to cool. And if the sun is releasing more energy, it causes the Earth to warm. So in the distant past, low radiation output times in the solar cycle would result in small ice ages, whereas in the past, global warming could be caused by high energy outputs by the sun. The reason we know that this isn't what's causing our present day climate change or global warming is because the sun is currently in a period of low solar output. So we would expect, based on the solar radiation that the Earth is getting, for the Earth to be cooling. Since the Earth is actually warming, we know that solar output is not what is behind present day climate change. The second is volcanic eruptions. So we talked about this briefly already, but when a volcanic erupts, it puts lots of ash and greenhouse gas into the atmosphere. The ash can block sunlight, resulting in temporary cooling until it settles back down to Earth, but the greenhouse gases remain in the atmosphere much longer and can cause long-term warming. However, today's volcanic eruptions are significantly smaller and less frequent than what they were in the distant past when they had a large impact on climate. Moreover, volcanic eruptions nowadays actually cause a net reduction in greenhouse gases being put into the atmosphere, and that is because of their effect on air travel. When volcanoes erupt, it grounds planes that would normally fly through that airspace because it's really dangerous for planes to fly through volcanic ash. And planes emit a lot of greenhouse gases. And so when you ground that many planes, even though some carbon dioxide is getting put into the air because of the volcano itself, there is less carbon dioxide and other greenhouse gases going into the air in total because there's fewer planes flying. So they actually tracked this, this was probably about a decade and a half ago now, when the Iceland volcano erupted and grounded flights between North America and Europe, as well as flights all over Europe, and noticed that the net amount of carbon dioxide went down in the atmosphere during those months. So because of that, volcanic eruptions nowadays tend to actually cause, or should cause, a net cooling. And then lastly, the natural greenhouse effect. So the amount of greenhouse gases in the atmosphere always affects climate, and more greenhouse gases mean more global warming. In the past, when we had a lot of major extinctions and really rapid evolution happening, essentially because the Earth was developing so quickly when it was young, plants and animals also developed quickly, I mean, in terms of evolutionary scale. And the new species that evolved could change the amount of carbon dioxide in the air. And we'll talk about this when we get to our lesson on Earth's atmospheric composition in Bio 20. But essentially, you know, you had cyanobacteria evolve to use up carbon dioxide in the air, at which point carbon dioxide levels dropped. And then you had, you know, large trees evolve, and they also took carbon dioxide out of the air, so carbon dioxide levels dropped. And then you had bacteria evolve to break down dead trees, and that released carbon dioxide back out into the atmosphere. And then you had animals evolve, and that also released carbon dioxide back out into the atmosphere. So there was these fluctuations when you had entirely new categories of organisms evolving, which caused very natural fluctuations of carbon dioxide. However, carbon dioxide levels then became stable for tens of thousands of years because we don't have any new categories of like kingdoms and phylums and stuff like that evolving. So the only thing that has changed in terms of like CO2 production is the Industrial Revolution. Humans burning fossil fuels and releasing carbon dioxide out into the atmosphere that way, which is not part of the natural greenhouse effect. That is a man-made greenhouse effect. So let's look at some of these current causes of climate change. Obviously, a big one is the burning of fossil fuels, which releases carbon dioxide and other greenhouse gases into the atmosphere where they trap heat. Another one is urbanization. So urbanization we've talked about before. It's essentially the building of more urban spaces or cities and stuff like that, which tends to result in deforestation because you have to make space for those cities. It also causes, you know, when you have more roads and more buildings and stuff like that, you have less albedo, so less reflectivity, more absorption of the solar energy, which leads to heating. Speaking of which, deforestation, where you cut down trees, also results in more carbon dioxide in the air because trees take carbon dioxide out of the air, and if you have less of them taking carbon dioxide out of the air, then you end up with more carbon dioxide in the air, obviously. And then agriculture also tends to result in deforestation because, again, you need to make room for those fields. That's not true in everywhere in the world. Some places have naturally occurring grasslands, but we have a lot more forested areas in the world than naturally occurring grasslands. So usually in order to make farms, you have to cut down trees. And then you also have things like ungulates, for example, cows, that produce a lot of methane gas, which is a greenhouse gas that's actually even stronger than carbon dioxide in terms of its ability to trap heat. Ozone depletion is another issue. So chemicals that we have used in the past have created holes in the ozone layer, which means that less of the solar energy from the sun is filtered out before reaching Earth, which means more heating of Earth. All of that heating has resulted in the melting of ice caps and glaciers. So the melting of ice caps and glaciers, as well as sea ice, is an impact of climate change, but it also causes climate change because the fewer glaciers and ice caps and stuff like that that we have, the lower the albedo. The lower the albedo, the more solar energy is absorbed, which means more heating. This is the positive feedback loop that we talked about before. So all of that is the causes of climate change, but what evidence do we have that climate change is even actually happening? Well, first of all, every single scientific community around the world agrees that climate change and global warming are happening, that the impacts of them are happening, and that it's human caused. That's like not up for debate in terms of science. And there's very few things that all scientists agree on. There's even something like evolution is debated in the scientific community. Not that evolution is happening, but how evolution is happening. There's different theories of evolution that are competing. Anyway, my point is, it's very rare for scientists to just like across the board agree on something, but in terms of climate change and global warming, they do. And that's because we have so much evidence of man-made climate change. So let's go over some of it. The first is temperature measurements. Scientists have been measuring atmospheric, land, and ocean temperatures, both on the global scale and in local regions for decades now, and we can see from those measurements that the temperature of oceans has been steadily increasing, and then local land temperatures have been experiencing major shifts. So again, on land, we don't necessarily see the same constant increasing trend in every local area because there are some areas that are getting colder, but we do see these major shifts. But again, if we average all of those temperatures, they are increasing. Glaciers melting. This has become, a major concern, kind of anywhere that has mountains, that we have seen major glacial retreats. In the Alps, they've had a lot of glaciers just completely disappear. And I think it's France and Switzerland. They're actually now, like in the summer months, covering their glaciers with this like white insulation to try and protect them from melting, so that they don't lose all of their glaciers entirely. But it's not feasible to necessarily cover every mountain with insulation. But yeah, pictures that go back many, many decades can be used to compare that. So these two top pictures here compare this glacier between 1941 and 2004. This is taken at the same time of year. And in this first picture, the glacier goes all the way to the bottom of the picture. In the upper glacier, you only have the glacier remaining in the upper portions of the mountains. The rest is turned into a lake. Sea ice is also melting even faster than the glaciers because the water is warming up so quickly underneath it. The total amount of sea ice in the Arctic and Antarctic have decreased dramatically over the past few decades. This is a picture of the Arctic sea ice between 1979 and 2007. This is in the winter for both of these. And as you can see, there is a lot of melting of the sea ice in this general region here. There is still lots of sea ice This is Canada over here, by the way. This is like Baffin Island over here. So in our northern area, we do still have a fair amount of sea ice. As you get over towards like Alaska, which would be over here, and Siberia over here, you get a lot more obvious lack of sea ice. Vegetation and animal changes have also been tracked by biologists. Essentially, they're seeing how plant and animal species and their populations have changed over time to see if they're responding to climate change or not. And essentially, a lot of plants and animals have either died out or moved in order to try and access habitable areas as their normal habitat becomes uninhabitable. And that could be, if we're looking at like polar bears, a lack of sea ice is making them have to move further inland, and usually into like human settlements and stuff like that in search of food. Precipitation measurements have also been tracked by scientists for decades to identify major climatic shifts. And we have seen both dramatic increases and dramatic decreases in precipitation in different parts of the world. So you have some areas that used to experience a major flood like every 100 years. It was like this fairly rare thing. And now like every year or two, they're getting one of those 100-year floods. It's just becoming a part of that normal climate when it used to be a really rare phenomenon. And then in other areas, you have places where, again, they might have had a drought every now and then, and now for the past 30 years, they've been experiencing a drought. Sea level measurements have also been tracked by scientists for decades, and through that, we can just see that the sea level is continuously rising and has been for the past couple of decades. There are some island nations that have already had, not their entire nation, but like some island communities that have had to completely abandon their community because it is now underwater. And there are entire island nations like Kiribati, which are saying that within the next few decades, they're going to have to, all become refugees. That entire country is going to have to become a country of refugees because their country will be underwater. And this is happening for two reasons. I don't know if I have it on. This is happening for two reasons. We're probably going to talk about it when we get to some of the impacts of climate change, which overlap a lot with the evidence of climate change. But there's two reasons that sea levels are rising. One is because the water is warming up and warm water expands, so it takes up more space. And the other is because of all of the melting sea ice. And then we have tree rings, which have been studied by botanists that can look at, if you look at a really old tree, rings, you can essentially see some of the climatic patterns in the past. So in a tree's ring, you can actually see like if that year of growth had a lot of water, or was it a drought? Did it experience a fire? All of those things can be interpreted from a tree's rings. So you can essentially see, is there a pattern to the climate of like a cycle, or is it like a decline or an increase in the amount of precipitation or the temperatures or something like that. Ice cores, also super cool. They have been studied by scientists for decades now as well. Essentially, they take one of these big like ice borers and they drill way down into a glacier, usually in like Antarctica or Greenland or in the Arctic. And then they can analyze that rain by rain. So each one of these light and dark rains is like a winter and a summer. So every pair of light and dark rains is a year. And so they can just kind of like count from the top down through all of the different years, and then they drill into one of those years and take out a sample of ice. And from that sample, they can see how much carbon dioxide, how much methane, how much oxygen was in the air at that time, based on what gas bubbles are trapped in the ice for that year section. So they can use the data that we have already on temperatures and stuff like that, and compare it to the amount of different greenhouse gases that were in the atmosphere at that time in order to see the correlation between them. So that's just some of the evidence that we have of climate change. Again, it's not something that is up for debate in scientific communities. And now we're going to look at the impacts of climate change, which do overlap with the evidence of climate change because we use a lot of these impacts as evidence that it's happening. So higher temperatures, obviously. Higher temperatures, not often beneficial. The last decade has been the warmest ever on record, which has led to a lot more heat-related deaths, as well as heat-related illnesses, which can lead to other problems, which we'll talk about later. Melting sea ice obviously causes decreased albedo, also means that there is decreased habitat for our polar animals like polar bears, and the melting sea ice is also going to affect the oceans that it melts into. Not only will it cause rising oceans, but it also affects ocean currents, which is our third point here. So when you melt sea ice into the oceans, it's changing the salinity of the ocean in that area and also changing the temperature of the ocean in that area, both of which are factors that affect ocean currents. And it is hypothesized that if the current rate of sea ice melt in Greenland is maintained, the ocean current in the North Atlantic is going to stop or reverse direction, which would mean an ice age for Europe. Which would not be beneficial. And then, of course, melting sea ice and glaciers also causes rises in sea levels because of the ocean warming and the new water being put in. So that's obviously going to lead to coastal flooding. Many cities on coastlines will end up underwater if the current trend continues. It's estimated that about 100 million people will be displaced in the next 100 years because of rising sea levels, including the entire east coast of the United States and some other entire countries like we're already talking about. This will obviously affect human migration. Many human populations will be forced to move because of those rising sea levels or because of desertification, where you have a desert forming because of a long-term drought, severe weather, famine, again, because of a drought or something like that. All of those can force people to move, which will worsen our refugee crisis, and can cause more conflict between people as they fight for the limited amount of space and resources that we will have left. Diseases also spread more rapidly in warmer climates. That's just it's the reason why a lot of places near the equator tend to have higher rates of diseases than places near the Arctic. And vectors which spread diseases like mosquitoes can also travel further and exist in more places because they need warmth to survive. So for example, there used to be a lot of communities that were built like up the side of like mountains above the mosquito line, so above where it was like too cold for mosquitoes to live. And now, because of global warming, the mosquitoes can now exist in those villages. They have expanded their territory, which has increased the rate of like malaria and stuff like that, yellow fever. So yeah, it has caused more infectious diseases to spread. There's more diseases in the southern United States than there used to be. Zika was able to go there, stuff like that. Energy. More droughts mean that energy sources like hydroelectric power, nuclear power, and fossil fuel plants will not be able to run as often or produce as much energy because all of those rely on water. And then severe weather can also damage things like oil rigs and power plants, which could also lead to energy shortages. And I mean, this has happened as recently as, Hurricane Katrina and stuff like that in the Gulf of Mexico. Habitats are also changing. Desertification is becoming more common, and then plants and animals are again having to move or are just dying off as their habitat becomes unsuitable for their survival. Because of this, we are seeing a lot of biodiversity loss where species are going extinct because they just can't adapt to how quickly the environment is changing. Because of an increase of both droughts and flooding, famine is becoming more common because agriculture is suffering. Economic loss can also result because of agricultural failures, severe weather, more health concerns, all of that kind of stuff. And then severe weather is also becoming more common. So we know that things like hurricanes become stronger, and really strong hurricanes become more common as the oceans warm. Hurricanes get their energy from warm water. So yeah, hurricanes become more common, droughts, floods, typhoons, all of that kind of stuff. Severe weather, by the way, refers to any dangerous weather phenomenon that has the potential to cause damage, disruption, or death. It is caused by climate instability, so climate change will lead to more storms. Many storms gain strength by having access to warm air or warm oceans. And yeah, severe weather includes things like hurricanes, tornadoes, droughts, floods, ice and snowstorms, heat waves, etc. The last 5 years have broken a ton of records in regards to severe weather. The impacts of severe weather include social impacts, economic impacts, and environmental impacts. Social impacts are essentially the fact that travel is inhibited, communication can be inhibited. So like if a storm knocks out the power or blocks roads, something like that. Death is considered a social impact, so is the increased spread of disease, the decrease in food and resource availability, the damage to or the loss of homes, the displacement of people, all of that kind of stuff. Economic impacts are anything that costs money, and storm damage tends to be very expensive. People also aren't necessarily able to get to work. In the US, they spend over $500 billion every year because of severe weather, and again, that is expected to go up. I couldn't find any data on what that was in Canada, by the way. And then environmental impacts is anything that obviously directly damages the environment. So when you destroy man-made structures, that can cause pollution, a lot more waste. Say there's a flood and you have to like throw out all your furniture. It can cause chemical spills, it can cause oil spills, even as we have seen in the past, nuclear radiation leaks, fire, all that kind of stuff. Okay, so that is it for today's lesson. In the next lesson, we're going to be talking about some of the different ways that we can or possibly could in the future fight climate change.